Okay, good morning class.
Good morning, sir.
So today we're looking at analytical geometry, our second lesson, correct?
Yes.
So in analytical geometry we had to do for homework exercise 4.2. So we concluded the whole of exercise 4.1. We haven't done example 4. No. Alright, let's start there before we go into that exercise. Is that okay? So this is example 4 on page, sorry? Page 87. Okay, so here we are told in example 4 that if A, which is 6 and 0, B, which is 3 and 8, C, which is 7 and 5, and D, which is negative 1 and 2, are 4 points in the Cartesian plane. Show that AB is perpendicular to CD. So how are we going to do that? Good start, yes? Yes? The gradient of AB is? And the gradient of CD? And now we're going to prove that it's perpendicular. Multiply the two gradients. Absolutely. Right, nice. So let's work out the gradient of AB. So how do we work out gradient? y2 minus y1 over x2 minus x1. Okay. Now what? If you're going to go with A, which is 6 and 0, B, which is 3 and 8, if that is x1, y1, x2, y2. There's going to be 8 minus 0 over 3 minus 6, which is 8 over negative 3. Not so? Now we work out the gradient of CD. Okay, the gradient of CD is going to again be y2 minus y1 over x2 minus x1. So it's going to be 7 and 5, and D, which is negative 1 and 2. So it will be 2 minus 5 over negative 1 minus 7. This gives you negative 3 over negative 8, which is 3 over 8. Would they ever answer the question? No. Okay? Now we state the obvious. We say since the gradient of AB times the gradient of CD is equal to 8 over negative 3 times 3 over 8, which is equal to negative 1. Since that is the case, therefore AB is perpendicular to. Okay, any confusion there? Okay. All right. Example 5. Example 5 is on page. Sorry? Page 88. In example 5 on page 88, we are told that if E is the point negative 3 and 7, and F is a point 6 and P. The equation of the straight line L is 4y minus 9x equals 8. The question says in A, determine the gradient of straight line L. So how do you think we're going to get the gradient of line L? How do you want to do that? Anika? How did you get that? You're going to write the equation in standard form. Why in standard form of y is equal to mx plus c? Because when it's in standard form, we can draw the m value, the gradient. You all agree with that? So let's go with that. So a is going to be 4y minus 9x equals 8. But they get over the equal sign. So 4y is equal to 9x plus 8. Do I stop there? No. We have to make y the subject of the formula. So I divide by 4th rod. So y is equal to 9 over 4x plus 2. So can I conclude what the gradient is now? Yes. So therefore the gradient is equal to 9 over 4. Okay. Any confusion here? No? Let's look at B. B, they want to know the gradient of any line that is perpendicular to it. If lines are perpendicular, what do you mean? What do we know? The gradients are? Product of the two gradients is negative 1. If lines are parallel, gradients are? You will agree with that? So that means you say the gradient 1 times your gradient 2 is equal to negative 1. So what is the gradient of the first line? What's the gradient of L? 9 over 4. So it's 9 over 4 times the second gradient is equal to minus 1. So the second gradient is negative 9 over. Okay. Is that correct? You go following the textbook, am I right?
Yes.
Okay. So, in the next question we are told, what's the gradient of EF in terms of P? So EF in terms of P. So how do you work out the gradient? How do you work out gradient? Y2 is, Nela, look here, Y2 minus Y1 over X2 minus X1. For E, it's going to be negative 3 and 7, whilst F is 6 and P. If you make that X1, Y1, let's make that X2, Y2. So I want you guys to write down the gradient of EF in terms of P, using that coordinates. Do that quickly. Okay, so what do we have? Y2, so it's going to be P minus 7 over 6 minus 3. So it's going to be P minus 7 over 9. You all agree with that? Okay, let's look at D. D says the value of P if EF is perpendicular to L. As you can see there, we got the gradient of EF. Not so? What's the gradient of L? Gradient of L? Huh? 9 over 4. Not so? So, if EF is perpendicular to L, what does that mean? I multiply the gradient of EF, and I multiply the gradient of L, the answer should be negative. You will understand. What if it had said EF is parallel to L? What would you have said then? The gradient of EF is equal to the gradient of L, which is 9. You see the difference? Again, if the lines are perpendicular, the product of the two gradients is negative 1. Okay, so what is the gradient of EF? P minus 7 over 9 times 9 over 4 equals negative 1. So I'm going to work and get this on its own first. How do I do that? I divide both sides by 9 over 4. Can you see that? That means you say P minus 7 over 9 is equal to negative 4 over 9. So what do I do now? Cross multiply, yes, or? Get rid of the denominator, yes. Either or. Okay? Cross multiply, divide by 9, then P minus 7 is equal to negative 4. So P is equal to right, you guys got it? Why you look so confused, Anika? I mean, I don't confuse you. Okay, we're probably talking about something else other than maths. Okay. Let's see what would that value of P have been if it was parallel. Okay, this question was not asked. I'm just doing it one time. If lines are parallel, the gradient of EF would have been equal to the gradient of L. In other words, P minus 7 over 9 is equal to 9 over 4. Can you see that? Cross multiply. So I then get 81 is equal to 4P minus 28. So 4P is equal to 109. Just check if that's right. 81 plus 29. Correct? So P is equal to 109 over 4. Oh, that's going to be 100. It says 25. 9. So we'll give 2. So it's 27.5. And 25. Just check. What's 109 over 4? 27.25. Yeah. So that over there. But you guys understand the different approaches you use there. Okay. Then we went into exercise 4.2. So let's look at exercise 4.2 quickly. It's on page 88. Alright, so in exercise 4.2 we are told that you must prove that QS is parallel to ST. P, Q, S and T are the following points of the Cartesian plane. Any problems with number 1? No, so I'm going to do 1A. Okay? Just in case somebody does their work later on and they realize, but they have a problem. So prove that the lines are parallel. What do we prove? Prove that the gradients are equal. So it's y2 minus y1 over x2 minus x1. So it's P, Q, so it's going to be negative 1 minus 5 over 4 minus 2. So it gives you negative 6 over 6, which is negative 1. Now we work out the gradient of ST. Same story. So it's going to be 7 minus 3 over 2 minus 6, which is 4 over minus 4, which is negative 1. So we conclude, since the gradient of PQ equals the gradient of ST, which is equal to negative 1, therefore PQ is parallel to ST. That's how it must be laid out. Okay, yes, Michael?
You go straight into here.
No, you
You don't say this. Then your conclusion is not right. You're doing a half conclusion. Okay. So you must state the obvious. Make it a habit. Okay. I'm sure if they mark you outside your external exam and all of those things, they probably won't penalize you. Okay, but just add it in. This is the right way to do things. Okay. People, let's look at number 2. Any problems with 2A or B? Huh? No? I'm going to do 2A. They ask to prove that these points are collinear. What do we do when we prove points are collinear? Prove that the gradients are equal. So you now say the gradient of EF is changing Y with change in X. Okay, so we go with those two. It's going to be 4 minus 10 over 2 minus 4, which is negative 6 over negative 2, which is 3. So the gradient of FG, or I could have said EG, just do one of the two. The third one automatically will be equal if it is. If it's not in the first case, it wouldn't be in the second case. Okay, so that's going to give you 12 over 4, which is 3. So we say since the gradient of EF is equal to the gradient of FG, which is equal to 3, therefore E, F, and G are collinear. Why? The gradients are the same. Okay. Let's look at number 3. Any issues here? No problems with number 3? You say given the gradient of the straight line which are perpendicular. If it's perpendicular here, the product of the two gradients is negative 1. So if it's negative 4 over 7, what is the gradient of the second line? 7 over 4. B, negative 11 over 6. And C, 9 over 2. Is that negative additive inverse? Okay. In number 4, we are told that the gradient of the straight line is perpendicular to the straight line in that equation. Any issues here? A, right? Everything's the issue. Okay? So in number 4, the gradient of the straight line that's perpendicular. So in perpendicular, what do we know? The product of the two gradients must be negative 1. So let's go with A. So 4 is equal to 3 over 4x plus 9. What's the gradient of the first line? 3 over 4. Not so. So the gradient 1 times gradient 2 is equal to minus 1. So it's 3 over 4 times m2 is equal to minus 1. So the second gradient is negative 4 over 3. I know some of you could have seen it from here and gone straight into there. No problem. Okay, let's look at C. C is the issue. There's a different problem here. What's the issue here? It is not in standard form. So I must get it in standard form first. So I take divided by 5. So and then you have y is equal to negative 6 over 5x plus 2. So what's the gradient of the first line? Negative 6 over 5. So what's the gradient of the second line? The additive inverse of this? 5 over 6. Who asked this question? You understand, Michael? Alright, so do for me E, let's hear. You really understand? Go for it. What do we do first? Standard form. So we take that over. So 5y is equal to negative 2x plus 20. Divided by 5. So it's negative 2 over 5x plus 4. So what's the gradient of this line, of the first line? Negative 2 over 5x. So what's the gradient of the second line? There we go. Any other confusion? You all understand? Okay. Let's carry on with our lives. Take this page up. Right, let's look at number 5. Did I ask you to do number 5? Ask you to do the whole exercise. Number 5 and 6. Okay, any issues number 5? We are told that P, Q, R and S are points of the Cartesian plane. Prove that PQ is perpendicular to all this. So what do we do then? The gradient of PQ. Then the gradient of RS. We multiply together, you get an answer of -1. So therefore, they are perpendicular. Number 6, same story. Okay. So with that, you should be able to now do number 7, 8 and 9. Okay. So there we did this example today. Not so? Okay, that's the reason why I didn't give you that for homework. Okay, please do it. So many times it comes like this in your exam. Okay? So that's that there, people. Now we're looking at the summary of the gradients of a straight line. We know that the gradient of AB is equal to y2 minus y1 over x2 minus x1. We're given in that format that is used there. They tell you that xb cannot be equal to xa. Why do you think they say that xb can't be equal to xa? It will be undefined new denominator. Okay. People, number 1, we said if P and Q are any points on a non-vertical straight line, then PQ is equal to, right, that we know. In the second case, we know that if a line is parallel to x-axis, can you see it? Lines are parallel, not parallel, parallel to your x-axis, then that means to say your gradient is. That's what's coming out of me now. You see, it's almost weekend, almost. Right? People, if the line is parallel to x-axis, what does that mean? It means to say that the gradient is 0. So make a note there. Not on your hand, in my inclination. Copy. Make a note in your book. If a line is parallel to your x-axis, your gradient is 0. Okay. Okay, yes? Nope. Then, she's asking about the y-axis, and here's the note for the y-axis. If the line is parallel to your y-axis, then the gradient is undefined. The gradient of the vertical straight line is undefined. Okay. Okay, something we've used extensively. If lines are parallel, what do we know? Gradients are equal. Okay? The lines are perpendicular, what do we know? That the product of the two gradients is -1. We don't need to make this note. We know this already. Not so much. The inclination. People, we have heard the word incline, inclination. What do you mean? On the road, there we go. Okay, you get the incline. Incline is something that goes up, not so? Nice. And decline? There we go, right. So the inclination of a straight line is actually referring to the angle at which the line increases. Okay. So a note, we define the inclination of a straight line as the positive angle theta that the straight line makes with the positive direction of the x-axis where theta is greater than or equal to 0 or less than or equal to 180. Make that note quickly in your books. The inclination of a straight line, below that you write the following note. Right. People, which page are we on now? The first example of this is on page 90. 91. Okay. So then we are told that note, it's important to make a note of this here. We are told we define the inclination of the straight line as a positive angle. Oh, we've got the same thing, isn't it? Yeah. Okay, so now we can make this two diagrams here quickly. He says if both of these diagrams, theta is the inclination angle of the given straight line. Consider the straight line AB, which is this line here, in the diagram below. Theta is the inclination of AB, BAC is theta. Let's see here. So basically what they're referring to there is that this angle here is your inclination angle. Can you see that, people? If the line has a decreasing, if the line is decreasing, we have a negative gradient. Going to be there. So what do you know about this angle? This angle will be acute angle, while this will be an obtuse angle. Can you see that? If this gradient is positive, while this gradient is negative. You see that, people? Make that note. Well, what does acute mean? Acute means to say that the angle is less than 90 degrees, and obtuse is greater than 90 but less than 180. Okay. Now moving to force. Kinda. Okay. Kinda. But I'm not doing a writing. So you said writing slow. Okay. Understand now. I was wondering what is going on. I mustn't let you write. I said I mustn't let you write. Right. So let's carry on. So here we are told, don't write now. We can determine tan of theta using the trigonometric definition for tan of theta's intra-angle ABC. Okay. So tan of theta, the theta angle of course is lying here. Tan is opposite, which is BC over adjacent. Not so? So if tan of theta is equal to opposite, which is BC, over adjacent, which is AC. Okay? But is this not also change in y over change in x? But what do we actually calculate when we're doing change in y over change in x? Our gradient. Not so? So if tan of theta is equal to BC over AC, and the gradient is also equal to BC over AC, so what can we conclude here? The tan of theta is equal to the gradient. Absolutely. Make that note. Tan of theta is equal to the gradient. That's all you have to write. Now, tan of theta is equal to your gradient. Alright, you guys understand? Alright. Let's carry on. Yes? Yes, ask. You can, but for the angle of inclination, have we used the hypotenuse? No. So you're not going to use sine. Okay, unless this length was given here, the hypotenuse was given, and the adjacent, they're not going to use sine. We got opposite and hypotenuse, they're not going to use. Sorry, sine, and adjacent and hypotenuse we will use cos. But since analytical geometry we use the gradient often, not so. So then we will always be using, or most of the time we will be using tan, if not all the time. Okay, so as we explained here, if tan of theta is equal to CD, note that the gradient of CD is positive, thus tan is positive, hence the angle will be acute. Okay, we made that notice already. If tan of theta is equal to MQ, the gradient of MQ, note that the gradient of MQ is negative, thus tan is negative. Hence, here, theta is going to be an obtuse angle. Okay? Remember, if the gradient is positive, the angle is acute. If the gradient is negative, the angle is obtuse. Okay? By definition, the inclination theta is such that theta is greater than or equal to 0 but less than 180. Thus, we can conclude that if tan is positive, right, we did this already. Right, this is example 1 and this is on page 91. Example 1 is on page 91. Okay. Here we are told determine the inclination of theta of a straight line L. If the gradient of L is as follows. Work correct to 2 decimal places, Venus. So the first case, your gradient is 4. So is that angle obtuse or acute? It is acute. Okay? So what do I say? Tan of theta is equal to your gradient. Not so. So I say tan of theta equal. What's the gradient on this line? 4. So in other words, I'm working out theta. So how do I work out theta? Of tan of 4. Absolutely. So shift tan or arctan of 4 degrees. 75 comma 96. Okay, you all agree with that? Any confusion? No. So that angle that we have just worked out was that angle. You all okay with that? I'm moving again too fast. I feel like I'm moving too fast. No, now I'm not moving fast. Okay, B. Again, we must work out that inclination angle. So where do I start? I say tan of theta equals your gradient. So do your thing now. Yes, give everybody a chance. Your answer, Aaron? Is that between 90 and 180? No. No. But you're on the right hand. Right, so where do we go from here? We say tan of theta equals negative 2.
You said tan of theta.
Sorry?
So what did you say? Tan of what?
Theta. Okay, so tan of negative 2. So put that in the calculator, so we say shift tan or arctan of negative 2. Negative 63,43. So where does that angle actually fit in? That is actually this angle here. Can you see that? Remember, this is 0, 90, 180 and so on. In this direction, minus 90, minus 180, not so? And so on and so on. But we are interested in this angle here. So what do we do? Add 180. Why? Angles on a straight line. Not O, it's a theta, no? You can get confused sometimes. So we got negative 63, comma 43. But what do? I add 180 degrees, which is going to give us plus 180, 116, 57. 116, okay. If there any confusion? No. So if you want to make a note, if the angle is negative, add 180 degrees. Okay. The angle is negative, you add 180 degrees, you get the obtuse angle. Okay. You all okay with that? Example 2. In example 2 we are told, right, example 2 is on page Page 92. In example 2 on page 92, we are told, determine the inclination connected two decimal places where necessary of the straight line passing through each of the following pairs of points. So if you're looking at A, E, which is negative 2 and negative 4, F, which is 7 and 5. So how are we going to calculate this angle? What do we need? We need to know the gradient of EF, not so. So we say tan of theta is equal to the gradient of EF. How do you work out gradient? Y2 minus Y1 over X2 minus X1. Right, so do the substitution for A through 2. Alright, so what do we get? 5 minus minus 4 over 7 minus minus 2. Which gives us 9 over 9, which is 1, not so? So arc tan of 1, 45 degrees. You all agree with that? Okay. You guys saw the number 2 already? Yes? So tan of theta is equal to the gradient of QP. So work out the gradient of QP quickly. For those of you who didn't stop yet. Alright, so what do we have? So the gradient of QP is going to be 8 minus minus 2 over negative 1 minus 3, which is negative 4. Is that correct? So that gives me an angle of, or an inclination of, a gradient, sorry, of 10 over negative 4, which is negative 8 over and negative 5, sorry. Negative 5 over 2. I don't have to simplify it. No? So what do I say? Theta is equal to arctan of negative 5 over 2. Which is arctan of negative 5 over 2. Negative 68 comma. So what do I do? To add 180 to it. So your theta works out to be plus 180. Whoops. Plus 180. 111.8. 111.8 degrees. Do you have any confusion here? No, you all understand, eh? Alright, let's carry on with our lives. This is example 3 and it's on the same page, no? Example 3 on page 92. Here we are told, calculate the inclination of a straight line y is equal to the straight line y plus 3x equals 4, corrected 2 decimal places. So, if you got, didn't mean to cut this out, but we are told in order to determine the inclination of theta, we need to know tan of theta. Since tan of theta is a gradient, we first need to determine the gradient of the straight line, which makes sense. Not so. If we look at the straight line, which is y plus 3x equals 4, can I draw the gradient from it as it stands here? No. So what do? Take that over, get it in standard form of y is equal to mx plus c. So y is equal to 3x plus 4. What's the gradient of this line? Negative 3. So do your thing with the negative 3. Alright, so what do we have? Tan of theta is equal to negative 3. Not so? So theta is equal to arctan of negative 3. So we shift tan or arctan of negative 3 gives you negative 71, comma 56. Okay, so what do? Add 180 degrees, so the angle is negative. The 108 comma 43 degrees. Okay? Do you have any confusion? You all understand? Okay. So that basically brings us to exercise 4.3. The 4.3, I don't want you to do all of it. So it's basically the same thing being repeated all the time. Okay? So in number 1, I'd like you guys to do the first column. Number 2, the first column. Sorry? Is that all? Okay, then you can do all. No, I thought it's much more than that. Okay, you can do all. Thank you for pointing that out. It's a pleasure. Okay. We can start with it now. We've got a couple of minutes before the bell rings. Aaron, why you look like it?
I'm just tired, so.
Tired of looking like it, okay? You're pulling your face there. And I'll stop the video at this point. If you have a problem with this work, you can bring it to me now.